Hey, what's going on everyone? Welcome to Triggered Precision Machine. We have a great episode for you guys today. Before we kick off the episode, I want to remind you guys that the TPM KYL, that's the Know Your Limits Challenge, is still live. And what I've decided to do is extend it out until December 1st. So this is a really busy time of year. Some people are already prepping for holidays. We're out hunting, we're prepping for winter, we're doing all these activities. So it takes time away from our daily lives. And I want to make sure that as many people as possible get a chance to shoot this competition because it's been pretty fun to receive the targets in my email and see what you guys are doing out there. We've had a lot of good submissions lately. There's one particular gentleman who is currently the leader in the pack, so get out there and do it your best and see if you can beat him. But the target is downloadable off the website, www.triggeredprecision.com. The contest does not cost anything to enter, and the instructions are written for the most part on the top of the target. So download it, print it, staple it up on your target backer, shoot it, email it to me, and we'll get you entered. Aside from that, we have our nice, fresh, Triggered Precision Machine black sweatshirts in. They came out really nice. So if you guys want one of these, there's still a bunch left. They're on the website for sale right now. I'll get it boxed up and shipped out to you as soon as I can. So for today's episode, we're gonna talk about chamber reamers or chambers. This is a very, very important topic. There's a lot of good information we're gonna talk about in the next few minutes, and it's information that is useful to even the most basic shooter to understand the why behind what is going on with our rifles. So we're gonna talk about that in semi-detailed fashion, and we'll go over as much as we can and help you guys kind of understand what is what when it comes to chamber reamers and reading a chamber reamer print. So let's take a look at that. But before we do, let's take a look at this rifle in front of us. So this one, I will mention this again at the end of the video. For those of you who don't stick around till the end, this rifle will be up for grabs here in a few days. This is a 6.5 PRC. This is built off an Aero Precision Solus short action with a mag bolt face, a Proof Research barrel, a AG Composites Hunter stock, Hawkins Precision Hunter bottom metal with a Hawkins Precision Hunter mag, and it also comes with this MDT bipod here and a Salmon River Solutions titanium 3-port brake. Right now this rifle weighs 7.5 pounds, so it is a fairly lightweight rifle. This would be a perfect Western mule deer rifle. So this is going off for skim bedding here next week, and I'm going to do the Cerakote job on the exposed metal portions of the barrel and class it up quite a bit. So keep your eyes out on the website. It will be listed for sale. That's enough of that. Now let's get into the nuts and bolts of what we're going to talk about. All right guys, so let's start out with the basics. Let's talk about SAAMI, what SAAMI is. So SAAMI is an acronym, S-A-A-M-I. SAAMI stands for the Sporting Arms and Ammunition Manufacturers Institute. This is an organization that was created back in the 1920s, so it's almost 100 years old, at the request of the federal government to provide a standardization in the firearms industry for safety, interchangeability, and general quality. So when we're dealing with these things, you need to have some sort of standardization. So when you buy, let's say 6.5 Creedmoor ammo from one manufacturer, it'll shoot in another manufacturer's rifle. So we have to have that interchangeability and safety measure built in there. So that's what SAAMI does. We have the term wildcat cartridges. So what those are deviations from a SAAMI spec cartridge typically, and the shooter or gunsmith will make changes, dimensional changes to the cartridge, have a reamer ground, and that becomes a wildcat cartridge. So that is not a SAAMI adopted cartridge at that point. That's a wildcat cartridge, so there are no standards there. So you gotta be careful with what you get. The other one is CIP, and right off the top of my head, I cannot remember what CIP stands for, but basically think of it as the European version of SAAMI. So we have several European cartridges coming over here now. For example, the 338 Lapua has a CIP standard and a SAAMI standard. So there's two different reamer prints out there with slightly different variances in throat length and a couple other things on the reamer print. So now that we have that kind of hashed out, we kind of know what SAAMI is because you hear this term quite a bit in the precision rifle world. Let's talk about what a SAAMI reamer print looks like and what we get when we pull one up. So On the website, the SAMI website is actually a paid subscription website, but they do offer some free reamer prints right there, and you can click on those on the front page. And I have a 6mm Creedmoor reamer print and a cartridge print pulled up. So let's go over those, and we'll start with the cartridge print. We'll kind of go over some of the nomenclature, what some of the numbers mean. There's a lot of numbers here. You don't need to completely nerd out on what all this stuff means, but it's kind of interesting to know, especially if you're dipping your toes in the precision rifle world. It's kind of nice to know the why behind what goes on, especially if you are building a custom rifle or you're looking to have one built. So let's take a look at this 6 Creedmoor reamer, or the cartridge print, sorry, and we'll go over that kind of in sections. And I have some stuff all laid out and it's circled in red, so it'll make it easy for us to follow along, and we'll discuss what we see there. All right, we have our 6mm Creedmoor SAMI spec cartridge print up on the screen now. We have a lot of information here, so we'll go through it as best we can. And once again, this is not a be-all end-all class on reading cartridge and chamber prints, but this is just enough to make yourself dangerous and understand kind of what we have going on here. So at the very top, we have our velocity information. So they have a 108 grain bullet at 2950, and we have some maximum average pressure information at 62,000 PSI. The chamber print was issued on June 14th of 2017. And if we go down and look at the left side of the print, I have a section outlined in a red rectangle. So that's going to be our case head. That's where everything starts. That is the basis for our headspace. That is what interfaces with the bolt on our rifle, and generally a pretty important piece of the puzzle. Continuing with our nomenclature, we'll move to the middle of the cartridge, and what we have outlined in red there is the cartridge body. Just ahead of that, we have the cartridge shoulders. So this is a bottleneck cartridge, so we have shoulders on it. We also have straight wall cartridges, which obviously do not have shoulders, like a pistol cartridge or some of the old cowboy rounds. This 6mm Creedmoor has those 30-degree angled shoulders right there. All right, just forward of the shoulder is the case neck. That's another important piece of the puzzle. That is what retains our bullet. So if we back up just slightly, what I have outlined in the red box towards the front of the case there, just over the shoulders, is our headspace dimension. So what that is it is a datum line that is picked out in some area of the shoulder. So you can see it's not quite in the middle of the shoulders there. And what that does is create an imaginary plane through that line that measures back to the case head like we talked about before. And that's where we get our headspace dimension. So outlined below that in red, we have our actual headspace dimension and the tolerance for that. So 1 inch 543, and that's a -7 thousandths tolerance on that. So that is a very, very important number, probably one of the most important numbers on this cartridge print. So some of you might ask why we're looking at a cartridge print, and we're just looking at it because that is part of the SAMI package. So they release a cartridge print along with a chamber reamer print. Unless you're actually in the business of manufacturing ammunition, then we really don't care too much about the cartridge print unless you have maybe a piece of brass that you think is just way out of whack and you want to measure some sort of dimension on the brass and compare it to the SAMI spec. Then that's what we would use this for. So let's take a look now at a chamber reamer print. All right, now up on the screen we have our 6mm Creedmoor SAMI spec chamber print. Now previously I called this a chamber reamer print. That's technically not correct. This is a chamber print, although you would use these same dimensions to grind a chamber reamer. So outlined in red, we have our headspace once again, super critical dimension. What's interesting on this chamber print is we have a min and a max. So we have 1 inch 541 for our minimum, and we have 1 inch 551 for our maximum headspace. So what that equates to is a 10 thousandths 0.01 spread between min and max, which is a country mile. That is a ton of room. How this corresponds to gunsmithing. When we're chambering a custom rifle, we have to set headspace. So we use a set of gauges called a go and a no-go gauge. The go gauge generally corresponds to our min reading down there. So our 1 inch 541 would be our go gauge. If we can get the bolt to close on a go gauge, we know we at least have the minimum headspace. Going below that can also cause unsafe conditions, as well as going above the max. That's why we have that tolerance in there. So once we close on a go gauge, we know we at least have the minimum. Now we also use a no-go gauge which is somewhere in between the min and the max. It isn't at the max, but it is definitely more than the min. And what we want is for the bolt to not close on the no-go gauge. If it does close, we're not necessarily sunk. We just might have a little bit more headspace than what we want. But there is also what is called a field gauge. Now, a field gauge is right at the max headspace dimension, and anything over that is typically unsafe to use. So if your bolt is closing on a field gauge, you're sunk. Shelf it and get it fixed. So hopefully that clarifies a little bit of that. Some people think that the go is automatically the min and the no-go is automatically the max. So that is not the case. Typically in custom rifle building, we try to keep the headspace as close to the min dimension as possible. And what that does is it keeps the headspace tight, so our brass has to grow less, because most of our reloading dies are built to a SAMI spec. That is the standard, as we talked about previously in the video. So we're sizing less technically if we keep our headspace a little bit tighter. And from what I've seen in the last 20 years, that works pretty well. And you can definitely tell when you have a chamber that has what I'm going to call excessive headspace, not at the max, but maybe towards the max more than the min. And you can definitely feel that when you're sizing your brass, and it makes a difference in the life of your brass, and I think it makes a difference in the accuracy as well. So moving forward. All right, now we'll take a look at our neck diameter on this chamber print. We have two dimensions for our neck diameter called out on the print. The first is right there at the neck shoulder junction, measurement of 0.2770, and the second one is right there at the mouth of the neck, also at 0.2770. Now, what we have to keep in mind about this dimension right here is there's clearance built into this dimension to allow the case neck to expand to that dimension and cleanly release the bullet and send it down the barrel. So if we take a loaded round of 6mm Creedmoor right here, and what I have is Lapua brass, and this is a 115 DTAC, there's about 1.5 thou of neck tension on this bullet, and it measures 0.270. So that gives me 0.07 of diametrical clearance around this case neck to allow that case neck to expand and release the bullet. And that's just about what we want. Bench press shooters will commonly design custom reamers with as little as 1/1000th of an inch of neck clearance. So typically between 1 and 3 thousandths, that's what those guys like to run, from what I understand. One thing we do have to keep in mind is when we run a neck that tight, typically, I would say almost always, these guys are going to expand the neck of their cartridge case out to a known diameter, a known inside diameter. Then they're going to take a cut on the outside diameter. So what that does is, with the inside diameter being a known dimension, they take a cut to a known dimension on the outside, and they do that for all of their cases straight across the board. So the wall thickness of the neck is identical, or as identical as it can be, for all of their matched brass. So once they do that, they shave just a couple thousandths off of the outside diameter of the neck to make sure it's all even. And once they put all this work into the brass, the one thing that you don't want to do is overwork your brass when you're shooting it and when you're sizing it. So if you keep this neck dimension low, like we talked about in that 1 to 3 thousandths range, then the neck only expands very little, and when you size it back down, you're sizing it very little. So there's very little movement in the brass to work harden it and eventually ruin it. So these guys, very common for them to get 30, 40, 50 firings out of a piece of brass that they use. And once again, after you put that much work into prepping their brass, usually weight sorted and a whole bunch of other stuff that they do, you want to make it last. So that is not really an option, in my opinion, for someone like a PRS shooter or hunter or even a recreational shooter. You introduce the potential for problems at that point with running a tight neck chamber like that, unless you're shooting it in a very controlled environment like the bench rest guys are doing. So any sort of grime, grit, or dust that gets in there on those chambers, it's going to foul things up pretty good. And once again, the whole point of SAMI is to add reliability, interchangeability, and safety into these reamer designs and whatnot. So that's what that excess clearance gives us. It gives us those three: reliability, interchangeability, and safety. So pretty interesting stuff. That's a pretty important dimension here to understand kind of what that means. And if you do get a hold of a tight neck chamber for some reason and your gunsmith reams your rifle with a tight neck chamber, you will know it, because first of all, the case might not even go into the chamber because the variances in different manufacturers' brass thickness vary widely across the board. So you might not even be able to get it in there even when it's sized. So keep that in mind, and if you do run into that, that's something that needs to be changed, or you need to end up turning the necks of your brass like we just discussed to make them fit. So that's about it for our neck diameters. All right, now we're getting into some really interesting stuff. The little red box you guys see on the screen just ahead of the case neck, that's going to be our freebore. Now, what is freebore? Freebore is the unrifled portion of the chamber just ahead of the neck that the bullet sits in prior to entering the lead and going down the barrel and lands in grooves. So there is no rifling in that portion and no contact of the bullet against that diameter right there. So we have two dimensions. We have a start and an end. The start is just forward of the case neck. You see there's a little angle going down, and all that is so there's not an abrupt angle, and that gives us a little bit of tolerance in our overall length, our trim length for our case. So we have our start dimension of 1.9418, and we have our end dimension of 2.1247. There are some chamber reamer prints that will actually do the math for you and show what the freebore is. So we have to do the math on our own on this one. So up at the upper left-hand corner, we have our two dimensions there. 2.1247 minus 1.9418 gives us a 0.1829 inch freebore. Now, what does that mean for you, your reloads, or shooting factory ammo? So like we discussed before, these SAMI spec chambers are built with interchangeability in mind and safety in mind. So the freebore on this, I can tell you right now, is pretty generous. In fact, I shoot my 115 grain DTACs out of this exact SAMI spec chamber without any issues. A lot of times though, folks will want to have a loaded cartridge, or I'm sorry, a bullet seated at a very specific depth. So we like to have that bow tail bearing surface junction right there at the neck shoulder junction of the case, so we don't rob ourselves of case capacity. And if this freebore does not suit that, meaning we would be cramming the bullet into the lands because the freebore is too short, then we have to lengthen the freebore. And that's a pretty easy operation that can be done on a case-by-case basis with a dummy round for your chamber. So typically we'll start out with the SAMI spec chamber, and that will usually satisfy 99% of people's needs. If we need to deviate from that and lengthen out the freebore, that is no problem whatsoever. But that is a very common thing to change, and it's becoming more and more common as we have these heavy .4 caliber bullets popping up. Like we have the 115s for the 6mm, and we have the 156s now, or whatever they are, for the 6.5s, 245s for 30 caliber bullets. Or so there's a lot of these heavy bullets, and with the weight comes the length. So the length has to go somewhere. It's either going to go into the case, which robs us of case capacity, or it's pushed forward into the bore. So that's where we have to have our free bore pushed out to accommodate the bullet. And we have one last little box there at the top. That's going to be our free bore diameter. So that gives us the clearance around the bullet. We have a measurement there of 0.2435. That's pretty tight. If we recall, this is a 6mm, which is a 0.243 bullet. I just pulled a 115 grain DTAC out of the box and threw a micrometer on it, and I got a measurement of 0.24295, which gives us ever so slight clearance around the diameter of the bullet. So it is technically not touching the free bore diameter right there. Now just forward of our free bore, we have the lead. So in the red box, we have a little dimension there, 1 degree 30 minutes, which is 1.5 degrees, and that's a very, very slight angle from the unrifled portion of the free bore into the bore diameter. So that allows the bullet to have a smooth transition into the rifling and start its path down the barrel. This is another dimension that is commonly changed in custom cartridge design and bench rest shooters to accommodate different bullet profiles. So you can tweak that angle right there to suit our different bullet profiles. So if we recall, we have secant ogive bullets and we have tangent ogive bullets, and each one of those has a slightly different angle where the bullet profile meets the bearing surface. So that's where that dimension would be changed, and it's just very, very slight change. It's not very dramatic. All right, the last thing we're going to talk about on this chamber print is bore diameter and groove diameter. They're at the upper right-hand corner. Now, we commonly hear the terms lands and grooves when we're talking about rifle barrels, and that's what this corresponds to. So our lands, that's going to be our bore diameter. Our grooves, that's obviously our groove diameter. We have dimensions there, 0.237 and 0.243 respectively. Now, what this means is these are the dimensions that our barrel manufacturers are trying to hit when they machine a barrel. Do they always hit these dimensions? No. There is always going to be tolerance or variance built in to the machining process for those barrels. So how that manifests itself in the real world is typically through velocity differences. So if we took two barrels that came off the exact same machine sequentially, there's going to be slight variances in the bore and the groove diameters. So if we took those barrels and we cut them off at the same length, finished them the same chamber, same ammunition, same environmental factors, everything else being equal, and we fired those through a chronograph, there is more likely than not going to be a velocity difference between those two barrels. Sometimes it's very slight, they could be very similar, sometimes it's more extreme. It could be 100 feet per second or something along those lines. It just has to do with, a lot of it has to do with the bore diameter and the groove diameter and the variance that we see in the manufacturing process there. So just something to keep in mind. And one other thing, I'll throw a picture of this up on the screen right now, but the major single point cut rifle barrel manufacturers like Brock's, Bartline, etc., generally those guys will stamp the bore diameter and the groove diameter on the shank of their barrel, along with their company name, what the barrel is made out of, and the twist rate for the barrel. So keep an eye on that. If you ever purchase a barrel, I usually cut those off and keep them and ship them to my customers because it's a nice little reminder of what you have on your rifle if it's not written down somewhere. All right, so that was kind of a basic introduction to reading chamber prints, reading cartridge prints, and hopefully you guys got something out of that. Now, that's just knowledge that even the average shooter can use, especially if you're looking to have a precision rifle built. Your gunsmith should be asking you what round you want to shoot, what your loaded round length is, can you provide me with a dummy cartridge? That is what I would expect when I pay the money to have a custom rifle built, and that's what I do for my customers. So if you want your barrel throated to a specific bullet, send me a dummy round and I'll make it happen. All right, all that being said, I'm gonna go out on a limb here and I'm gonna say that 90+% of my customers' needs can be met with a simple off-the-shelf SAMI spec reamer. So there are cases where we might need to bump the throat out a little bit for the long bullets like we talked about, but I'm gonna say 90% of people could live with a SAMI spec chamber. And the reason being is the dimensions on the SAMI spec chamber are pretty generous. Usually the throat is pretty decent and it'll accommodate a wide range of bullets. Now, a lot of folks get really wrapped around the axle about having that bullet placed exactly where they want it to be inside the cartridge case. They want that bow tail section of the bullet right there at the neck shoulder junction. It has to be right there. You know, if you're sunk into the case an extra 20 thousandths more than that, or 40 thousandths more than that, or even 50 thousandths more than that, is that going to make a huge difference? Not really, okay? You're eating up just a slight bit of case capacity, and in the end, is it worth punching out the throat? Maybe, maybe not. I'm not sure. That's a call that you're gonna have to make, but just know that some of these changes that we're making, the juice just is not worth the squeeze, and a lot of times it's just best to live with what we got. I am more than happy to throw a chamber out to whatever cartridge you're using, like I mentioned before, but a lot of times it's just not necessary. So it's best to kind of chamber it and we'll see where we're at and make sure that we can be magazine fed if that's a requirement, and make sure that we're not jamming our bullet way into the lands. And if the bullet is pushed way back into the case and we're eating up a significant amount of case capacity, then absolutely, let's try to resolve that issue and let's push the throat out so we can get the bullet seated out further and give you some case capacity back. Now, if you're chasing just a few feet per second and trying to wring the ever-loving daylights of performance out of your cartridge, then maybe it's time to step up to the next one. A lot of guys who run the 6.5 Creedmoors, they try to push them as hard as they can. And the customers that I have who want that and they acknowledge that that's what they're going to do, I try to urge them to maybe step it up to a 6.5 PRC or a 6.5 SOM or something that has a little more juice behind it to where you don't have to push it to the absolute limits to get the performance you want. All right, guys, so that's it for today. Hope that was informational and interesting to you guys. I kind of like that stuff, and I might get into doing some custom reamer design of my own just to experiment with here down the road. You guys have probably been looking and drooling over this rifle here on the table. So this rifle is going to be up for sale here probably next week. It's all pieced together. It's been function tested, so it's going in for Cerakote and bedding here next week. So this one will be up for grabs, and this is chambered in 6.5 PRC, and it is an absolute tack driver. And this is one of the new Aero Precision Solus short actions with a mag bolt face. So that's where we can run that 6.5 PRC chamber with that action. And this one has AG composite hunter stock, a Proof Research carbon fiber barrel, Salmon River Solutions Ti-Pro brake, so it's a titanium 3-port brake. Those are absolutely trick. And we have Hawkins Precision Hunter detachable bottom metal with a Hunter magazine down there. So really cool rifle, you guys. Check out the website. It will be posted up there next week for sale. That's it for now. Thanks for joining tonight, and keep an eye on the results for our TPM KYL challenge. And like I mentioned, we have till December 1st. So jump on the website, download your target, print it out, staple it up there, give it your best shot, email it back to me, and we'll have some cool prizes to deliver to you guys sometime in December. That's it for now, guys. Hope you guys are all doing well. Thanks for watching. We'll see you later.